Hello everyone. Today we will solve another equilibrium problem. Here the problem states a 2500 pound wheel with a radius of 3 feet is acted upon by a force F, figure 40, which is this one, which tends to pull the wheel over the obstruction at A at the instant the wheel is about to move. The pressure between the wheel and the ground is 0. What is the magnitude of the force F at this instant if theta equals 30 degree? So let's draw a free body diagram for the wheel. FBD, the short form of free body diagram. Then let's draw the major axis X and Y. Here the weight of the wheel is pulling it downward, and which is 2500 pound. And then the force F, which is pulling the wheel at this direction with an angle of theta, and then there's another reaction for the obstruction at A point, which is gonna be this way. Here if we solve it geometrically, here the radius is 3 feet. So the point at which A is connected with the wheel, the distance to the center is 3 feet. So we can write it as 3 feet. And then here it says that it's about the size of 1.5 feet in height. So if we think it as the radius here, which is 3 feet, and 1.5 feet is half of it, so we will get a height here at 1.5 feet. And if we use trigonometrical formula, then we can find the angle of it. So let's start. For that we will write sine theta for the A, so we can write it sine theta A equals our perpendicular distance here, or the height 1.5, and then our hypotenuse, which is the normal force or the reaction force of A. We can write it 3 feet under here. Then we can find the theta A, which is sine inverse 1.5 divided by 3, and let's put it in calculator. 1.5 divided 3, we get 30 degree. So we have found that this angle is 30 degree, and from the problem we can see that theta equals 30 degree, so this is also 30 degree. Then we can use the Lami's theorem here and figure out all the angles between them. So let's apply Lami's theorem. By applying Lami's theorem, the 2500 pound, which is pulling it downward, divided by sine the angle between the other two forces, which is this one, and if you want to find it, we can write it as alpha, and this is beta, and this is gamma. So let's find them here. Alpha, beta, gamma. For alpha angle we get 180 minus this 30 degree, and for theta, which is 30, so we will write out as 30, and then we will subtract those angles. We get 120 degree. Then for beta, it will be 90 plus theta, which is value is 30 degree, so we will add 30 degree here, and then we get 120 degree. For gamma, we will also get 90 plus 30, so it will be 120 degree. So let's write it down as this: 120 equal f divided by sine, which will be gamma, and we have found it as 120, so we will write it as 120, and then this normal force we can write it as R, and the angle between the other two forces beta equals sine 120 degree. And if we remove all the sine 120 degree, because we have it in everywhere, so we will use it as this. So in the question it says f, to find us the f, so the magnitude of the f will be 2500 pound. So that's it for this problem. Thanks for watching.